Hello, everyone, and welcome to the Adafruit Show and Tell. I'm Liz. I'm going to be your host this evening. If you would like to join the stream to show off your project, you can find a link in the live Discord chat channel on our Discord server, and you can get there by going to adafruit.it/Discord. First, though, we're going to kick things off with some Adafruit folks, and we're going to hear from Brent. Hey, Brent.
Hey, Liz. Sharing my screen. If you
Yeah.
can. Yeah, so tomorrow, we're updating the SSL certificate for Adafruit IO. Woo.
Okay.
We now have to do this every year. For embedded devices, it makes it annoying, but for the web security people, it's like, yeah, they're happy
Yeah.
about it. So it shouldn't impact anybody on Adafruit IO right now, unless for whatever reason you're using ESP8266. So like
Okay.
one of these feathers, they're older. Espressif really doesn't have them like produced anymore, but only if you like opt into this like fingerprint option. You have to change the code. And um but if you experience any difficulties tomorrow, you can go to the Adafruit forums and file like a new topic over here, and it should be fine. It should be good. But if you are using it, you should probably update your devices. And this is the first year we're actually like preparing for it a little bit more.
Okay.
It happens every year, and like last year, the root certificate changed underneath us, which is like really rare and like a once in a decade thing. But it
Yeah.
was really bad because it's like not just SSL certificate, but it's the root. So now like we have this whole like list of processes that's like, does it change the root? How do we get to new fingerprint? What libraries do we update? What do we test?
That's
So
great.
like this is just like to validate that everything works. So like I went through today. Now we have a baseline. Go through tomorrow, make sure everything's okay, and
Hmm.
it should be fine. And then next year, someone aside from me will do it. But this is the first step to getting some of our internal processes documented.
That's awesome. It's bringing me back to my IT days and change windows and things like that.
Yeah, yeah. It's not a fun thing, but just like
No.
something we got to do now.
Yes, yeah, and as long when you have a nice process like that, it's great and documentation for everyone. It all comes together.
Yeah.
Yeah. All right. Well, thanks
All
for
right.
sharing that, Brent.
Bye.
All right. Have a good one. All right. Next, we're going to hear from JP.
Hey
Hey,
Liz,
how are
I'm doing good. I am excited because I have gotten a Learn Guide published for this sequencer. If you can bring up here, this is this little 16-step knobby sequencer, I call it, because it's
you?
got
Yeah.
a bunch of knobs. And these are 4 sets of 4 rotary encoders on little seesaw breakouts. So there's just one little cutie pie there that is talking I2C to those 4 boards.
Okay.
You can actually have up to 8 of those boards on one I2C bus if you pick the right address jumpers, but I'm just using 4. And this is speaking USB MIDI to either a computer that you've got some software synthesizer running on, or whatever needs you have for some MIDI flying around. Or in my case, I'm using this little sample workstation called a black box. And I've shown this before, so I won't go into huge depth on it, but the idea is that we're just marching along, playing through, looping through this sequence. I'll turn on some sound for a moment here. So you can see notes are happening where there are lights and not
Yeah.
where there aren't. I'm going to dump my exposure a little so you can see it better. And I can change that muting state, or I can adjust a pitch by changing the knob there. So now it won't play there, and that'll be a louder note. And then I've got settings mode where I can go in and adjust all that, what scales I'm using, what the octave is. If I bring this
Wow.
in and
And so each color kind of denotes a different setting.
yes, that's right. Yeah, these are all similar in the middle because those are all different scales that we can pick from
Okay.
in different mode sets. So that there's new notes come in. We can also transpose the whole thing. Send it back down. Change tempo and so on. So turn it off. One thing I wanted to talk about is actually what I'm playing here is is not just a sample of a piano, but it's actually something called a multi-sample. And the
Okay.
idea is when you sample something, grab a microphone, put it by a piano, play a note. These kinds of machines on your laptop, they have the processing power to do a pretty good job of time stretching and pitch shifting things so that you can play it in, an octave or two. But to get things to sound good and get the harmonics to sound good, you'll often use a thing called a multi-sample, which if you look in this little folder here, when I hit load, turn on the audio, you can see this one house piano has been sampled a bunch of times, not for every note. You can do that, but if I go and scroll through, so that was a real piano being played and sampled, which sounds a lot different than trying to like play middle C and then the heck out of it. We can go all the way down to this big thudding low note. And these are the MIDI numbers on their MIDI note 24, which is a double low C or something like that. And so that is then taken care of by your software synth. You can get free synths that do this. This little sample station does this. And so when I am sending along MIDI messages as this sequencer is playing, it's picking from the nearest one and then stretching it to where it needs it, or we might be hitting one. One really neat thing that I've actually used this box for before a couple times, there's a nice little workflow for it to build a multi-sample from a synthesizer. So if you go grab some vintage synthesizer, this can form this little cycle where it'll send MIDI out and it'll bring audio in. And you can automate it to where it'll say, I'm going to play the lowest note and I'm going to sample that. And then MIDI from this goes and plays the next higher note over on the synth while this thing is recording that. And you end up with 88 little wave files or however you tell it to do, which is as good as it can get. So, you know, that's a whole art trying to make great sample packs from instruments. But a little neat trick that I thought I want to share was that's quite different than when I just take some funny little sound and pitch it around, which I'll demonstrate just for kicks. If I go, let's go back out to the pads here. So I'm going to tell this thing not to play any MIDI. And we'll come back out. Okay, that's a little funny little bassy sound. And that came from a sample. There's the sample that it's playing from. So I'll tell that to play with MIDI. Now I'm kind of clipping it shorter and stuff, so it's not a super fair comparison. But
I'm assuming that with the multi-sampling, why it's sounding better is you're getting more overtones from the different octaves, and that's you're able to get a better harmonic out of it.
Yes, absolutely. There's going to be richer, stronger, more accurate harmonics, I think, than trying to analyze very quickly a waveform and say, okay, this was the fundamental and these were the harmonics, and if we move all that, are we really accurately moving all that stuff along? So I think you absolutely start to get some clashing harmonics in computing those on the fly versus taking your time with it and pre-rendering it. It can do a better job, I think, but nothing better than nothing better than the real thing if I could actually play piano. But second best thing is to actually sample at intervals or every note if you like. And some people will even go, if you look for like really nice string and piano software on the computer, they will be sampled not only at lots of notes, but lots of intensities, because there's different things that happen when you play a piano key softly than hard. And so you'll have some that have been played with like 5 intensity levels every note and turned into this really impressive sample pack where you have these kind of 2 dimensions of the velocity it was hit at and what the note pitch was. And you kind of mush all that together and you get these really amazing like piano software packs on computers that people use, or inside, even built inside of some of the stage pianos, like the weighted key stage pianos. Those have really lush, beautiful, nicely recorded sample packs in them.
And someone in more of the DIY community does a lot of really cool sample packs is Dave Hilowitz.
Okay.
And he has a YouTube channel. He also does a lot of like DIY MIDI things and instrument repairs. So I think folks that watch Show and Tell will probably enjoy his stuff, and you would definitely enjoy his stuff too.
Oh, really? Yeah, thank you so much for that info. That's very cool. So that's it. This is wrapped up. I've got a Learn guide that just came out. If people want to go check it out and build their own little gizmo, they can. And I'll be launching off onto a couple of new projects tomorrow. So if you want to come by the workshop live stream, I will be playing around with fun stuff.
All right. Looking forward to it. Thanks for coming by, JP.
Thanks, Liz.
Have a good one. All right, that's going to wrap it up for tonight's show and tell. But don't worry, in about 20 minutes, you'll have Ask an Engineer live right here with Lady Ada and Mr. Lady Ada. So take this brief interlude to get a snack, and then tune in for that. So until next week, have a good one, folks. Bye.